Okay, so I am back. It is currently 5:50 p.m. where I'm at right now. I did the exam. I finished the exam at 12, so literally just under 6 hours ago. And yeah, so honestly, before I get into the actual paper itself, just want to talk about how I prepared for it. My main preparation for all these exams is just going through the problem sheets the lecturer has given us, because I kind of thought to myself, okay, surely the lecturer knows exactly what we're going to be tested on. So they're going to put certain emphasis on some things, less of an emphasis on other things. And I thought to myself, okay, whatever doesn't appear in a problem sheet, I can probably assume it doesn't appear in the exam. And that kind of worked for this exam. Um, just to show off my cheat sheet here, my university allows us to have a two-sided A4 sheet of notes for each exam. Um, So yeah, I showed off my linear algebra one for the last exam I did. This is my calculus one, and yeah, it's really empty, unbelievably empty. Um, yeah, that whole quote about failing to prepare is preparing to fail sums up this, to be honest. I never even used trig identity in the exam. Yeah, that one I just gave up literally. This one I didn't even need. I've got some Taylor theorem on here, second order expansions with multivariate equations, different sort of ODEs I could solve, uh, plotting phase planes as well. Um, that didn't even come up. Neither did any of this, to be honest. That did come up actually. That was quite a big question. About 20 marks based on this stuff right here. So I'm glad that that's there. This was also another 14 here, just double integration. I often forget which way each method represents on the graph. But yeah, this is it really. Yeah, so as I said, the main parts I used were this and that. There was one Taylor's theorem question, but that wasn't too bad though. Okay, but let's just get into enough stalling, let's get into the actual paper now. So here it is. There were 10 questions, and again, 100 marks. 50 marks were based on what I did in autumn term. That's more like pure calculus in a sense, so just like general calculus. And then spring term was much more heavily focused on differential equations. That's the second 50 marks of this paper. Let's get into it. So yeah, this one wasn't too bad. I just said let z equal, yeah. So yeah, show that if z is a complex number, then da 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 da. Yeah, I just said let z equal a plus bi, and just prove that really. This wasn't too bad either. Da, da, da. This one, I hadn't done a question like this since about October um, of last year. So actually, November is probably more accurate. But yeah, with the problem sheets that I did, I skipped the first five for each of my modules, each of my classes, purely because I thought to myself, okay, the first 5 weeks of lectures is so like basic, it can't really get examined on, and that worked for linear algebra. This, I believe, was mentioned within that first 5 weeks, so I couldn't really do it. It's an implicit differentiation question, and I gave it my best shot. I did get an answer, but this kind of tells me that there's supposed to be fractions here. I didn't get fractions, I got whole numbers, so that's a bit annoying. I think the mistake I made was here. You're meant to differentiate this like with a product rule. So yeah, then this becomes 2x minus 2y plus 2x dy by dx, and then plus 6y dy by dx equals 0. I didn't do that. I just said 2x minus 2y dy by dx, like regular chain rule, I think. So yeah, I messed that one up. Oh well. It's 10 marks, 10% of the entire paper. I should get some marks, but if I miss some, I wouldn't be surprised. This one was fine. This was the Taylor theorem question. Yeah, just a second order Taylor polynomial, nothing too crazy. Wasn't too bad. I got m to be, I believe, 179 walked out of the exam, people were either getting my answer 179 or 153, I think. So yeah, we'll see how that goes when the results come out. Okay, and now this one was just fine. Yeah, show that f has two stationary points. Identify the nature of each one. Just doing that with partial differentiation really. Show that fx is equal to fy, which is equal to 0. The coordinates of xy, when that's true, are your stationary points. I believe I got 0, 0, and the second point was 2 minus a quarter. Yeah, 2 and minus a quarter, I believe. I got the 0, 0 to be a saddle point, and then the 2 minus a quarter to be a local minimum. When discussing this question, answers were very, very varied. Some people got 2 maximum, others got a saddle point and a maximum. Some people got 2 minimum, so yeah, biggest question on the paper, I believe, as well. So, oof, that's a bit worrying. Oh well, though. Double integration. I used to be horrible at this, but after a lot of practice, I'm not too bad now. So yeah, drawing a graph really helped. I ended up reversing this order of integration, and just so that on that first integral there, I could just make it y equals 2x plus 3 on the top part, and then on the as the upper bound and the lower bound to be y equals x squared. I should read this out first actually. Let L be the finite region in the xy plane that is bounded below by the curve y equals x squared and above by the line y equals 2 plus x3. So yeah, it wasn't too bad there. I believe I got 96 over 5. Again, for this, answers were also very varied. I don't think I actually met anyone that got the same answer as me. Some guy said he got like 3,000 over 17, I think. Another person said they got like 30.5, so no idea here. Okay, this question here, okay, alright, we're back. So, determine the general solution of the first order ODEs below, all for x greater than 0. So individually, these questions aren't too bad, but altogether, I feel like it's easy to make mistakes and lose marks if you make a silly mistake. So yeah, my first thought was classifying these. So I said this was a separable ODE. I got this one to be near separable. I said this one was a linear ODE that you can just solve using the integrating factor method. And this one I said was exact. So yeah. I believe it's either exact or near separable equations that also have the that are also known as homogeneous equations, like homogeneous differential equations. We don't call them that in my class, we just call them near separable and exact. But yeah, the one that actually worried me a little bit was this one, because when I was doing the integrating factor method, the part where you do your integrating factor times y equal to the integral of this function times the integrating factor, I forgot to times this by the integrating factor. The integrating factor ends up being e to the x squared, which comes from e to the power of the integral of the power of y here. So we call so in this case 2x is p, and then your m equals e to the integral of p dx, which equals e to the x squared. See, I didn't, and then on the right hand side, once you do that, you end up saying m times y is equal to the integral of this function here times m. First, I actually forgot to times this by m, so I was trying to do the integral of just this, which was really hard. Then I realized, hold on, I didn't actually do that. I didn't actually times it by m. Did that, and things became a lot easier. This one was fine as well. Thankfully, I didn't have to use an integrating factor to make it exact. It's just exact as it is, so there's that. This wasn't too bad though. If I lost any marks on this question, it'd probably be on this one here, I'd imagine. Exact, actually maybe exact, because I'm rearranging the coefficients and choosing a constant and then putting that constant back into your original equation, into your solution. I always mess that up, so I wouldn't be surprised if I lost marks on part D here. Okay, and then question 7. This question. Okay, so question 7. Quickly read through this. My dog likes gravy with his food, provided it's not hotter than 30 degrees. I make it with water at 100 degrees Celsius at 5 p.m. 10 minutes later, its temperature is 60 degrees. Kitchen temperature throughout this time remains constant at 20 degrees. Assuming the temperature obeys Newton's law of cooling, i.e. that the rate of change of its temperature is proportional to the difference between its temperature and the temperature in the kitchen, when is the earliest my dog can have his food? Make sure to show all your working. So with this question, I remember I saw a similar type question here, like kind of making your own, like deriving an ODE from like a scenario, and I thought to myself, okay, this has appeared in like I'm pretty sure actually all 4 of the last 4 past exams. So I thought to myself, they won't do it 5 years in a row. Would you look at that? They did it 5 years in a row. So I didn't actually practice this question, which is unfortunate. And I also convinced myself that this law wouldn't be mentioned because it was mentioned in passing in a lecture. Turns out it was. It's not that hard though to like kind of derive. It's just yes, I just said the temperature of the gravy, the rate of change of the temperature of the gravy is proportional to the temperature of the temperature of the kitchen minus the temperature of the gravy, as that represents when the gravy is hotter than the kitchen temperature. dt with respect to dt by dt is a bit confusing. It's negative, so the temperature goes down. And then yeah, that wasn't too bad. Let's use a constant k. Doing this, I'm pretty sure I got my time to be 30 minutes. So then I got t to be 30 minutes. And then for 30 degrees, and then 30 minutes plus 5 p.m. is just 5:30 p.m. I was really happy about that because I got a nice number 1 and 2. I didn't actually prepare for it at all, so we'll see if it's correct though. A couple others got the same answer as me, but hey, it's alright. This one wasn't too bad. Determine the solution of the differential equation, second order ODE, inhomogeneous, not too bad. Can't remember my solution for the life of me. I'm pretty sure I got like sine plus 1 plus 2 e to the x or something. I don't know. This one was alright as well. No initial conditions this time, so just a general solution. I got like c1 e to the minus 3x plus c2 e to the minus x, I think. I honestly can't remember. I'm pretty quite happy with how this one went though. Not bad. Question. Final question of the paper. It is given that for each of these following pairs of first order ODEs, the unique critical point is at the origin xy equals 0. Yeah. In each case, determine the nature stability of the critical point, determine the gradient of any straight line solutions, and finally sketch their phase portrait in the vicinity of a critical point. Okay, so this one was fine as well, honestly. I practiced this kind of question a lot, so when I saw it, I was happy. But yeah, to solve this, basically, you create a matrix of these coefficients, which would be, in this case, would be 2 by 2. Find the eigenvalues of that matrix, and then the eigenvalues of that matrix will tell you the nature and stability of the critical point. I actually had that on my sheet, which is great. I'll just show you. I think I remember what I got these two to be. So yeah, I'm pretty sure I got A here to be, where is it? A stable node. Yeah, because both eigenvalues were negative and they were distinct, so it's a stable node. And then I'm pretty sure I got this one to be a stable spiral because these eigenvalues come out as complex. I think the eigenvalue was like -2 plus or minus I. Honestly, I can't remember, but yeah. It's a bit cut off there, but I should say lambda equals p plus or minus iq. If p is negative, stable spiral. So yeah, that's what I got. And yeah, that's the paper. Did this go better than linear algebra? It was a very good paper, I'd say. It wasn't anything too crazy. I'd say if it went for question 2, this one here, implicit differentiation, I would say it went better than linear algebra because the rest was fine, honestly. Like while I was writing it, I was pretty confident in all my answers except for this one. I know I got this one wrong. So yeah, I think I gave linear algebra an 8 yesterday, or last time I recorded a video. I think I'm gonna bump that up to a 9, so I can give this an 8. Yeah. So yeah, so that's that discussed. I have 3 more exams now, I believe. Yeah, 3 more exams now. One is on the 11th at 9 a.m. Next is on the 15th at 2 p.m. And then final one, Doomsday, Real Analysis, is on the 31st. So I've got a lot of time to prepare for that. Also at 9 a.m. And that's the one I'm mainly worried about. Actually, stats I think I'll be okay for. Foundations I need to work on a lot. Real Analysis, it's the class where I feel like no matter how much I work on it, it's very possible that like it all depends on the question really, that I get, if that makes sense. But yeah, that sums up this paper, shorter than the last one, because it wasn't as much to talk about. But yeah, I guess I will see you guys, when's my exam? Next Thursday when I talk about my foundations. Till then, have a good one.